Hi, this is problem 20 from the 2021 AMC 10A. For how many ordered pairs BC of positive integers does neither x squared plus bx plus c equals 0, nor x squared plus cx plus b equals 0 have two distinct real solutions? All right, a tricky problem. So in order to satisfy this condition, we have to focus on the expression that appears in the square root of the quadratic equation. So for this to not have two distinct real solutions means that the expression inside the square root has to be less than or equal to 0. So for the first equation, that means that b squared is less than or equal to 4c, and for the second equation, c squared is less than 4b, and b and c are both positive integers. Great, so how do we satisfy both of these sets of inequalities for positive integers b and c? That's kind of the crux of the problem. So I noticed that since these are symmetric in a way, it seems as though b equal to c might be one set of solutions. So let me just try to examine that just to get a feel for how this might work. So if I set b equal to c, just call that x, for 1, 2, 3, 4, 5, 6, and try to look at what the equation 4x is versus x squared, I see that those cross at 16 and for a value of x of 4. So it seems as though b equal to c will give us valid solutions for both of these inequalities, provided that the b and c fall within the range of 1 to 4. And I notice that if either b or c exceeds 4, then we're going to trip one of these inequalities. That's kind of unavoidable. So it seems as though we just need to search the space of b and c in the range of 1 through 4 to try to look for possible solutions. So let's draw a grid to search. So we have b 1, 2, 3, 4. We have c 1, 2, 3, 4. We've decided that this is valid for the sets of inequalities. That satisfies the sets of inequalities. That does. So does that. Now we have to look at the off-diagonal terms. And we notice that when the two integers differ by a lot, so c is equal to 4, b is equal to 1, then it's very easy to trip one of these equations. So c squared here would definitely not be less than 4 times 1. So this is not satisfied. The mirror image is not satisfied. C equals 3, b is equal to 1. That's not satisfied either. Neither is the mirror image, nor is this, or this. 2, 1. Now that seems pretty close. So if c is equal to 2, c squared is equal to 4, b is 1, 4b is equal to 4, so that's satisfied. B squared less than or equal to 4c, that too is satisfied. So these points satisfy the inequalities. So does the mirror image. That completes our search zone. We're not counting c is equal to 0 or b is equal to 0. So the number of points that satisfy the conditions is 6. So the answer is B, 6.